this. Instead of grouping, I'm going to rather use this. Items must stay together. Was it frozen? Okay. This is on page 17. Items must stay together. This is going to be a classic as well, guys, where things have to stay together. Maybe two friends, maybe three friends have to stay together. You can move them around amongst the arrangement, but they need to stay beside each other. Okay, so again, certain objects need to stay together. One more time. So let's do one example. An artist wishes to display her 8 paintings at an art gallery. How many ways can the paintings be arranged? This would simply be a case where if you have your fundamental counting principle, you've got your 8. You realize, oh, this is 8 all the way down to 1. That's just 8 factorial, which can also be written as 8 pick 8. That would be 40,320 ways. I don't think you're surprised by that. But what if it asked you, the artist wishes to keep her 3 favorite paintings together. So you're still having 8, but now you're saying, I have the 3 that I really like to stay together. Okay? How many arrangements are possible now? This is basically your universal, right? The 40,000, all possible. Now you're putting a restriction on that. So this is how I want you to think of it, okay? Let's do the 8 slots again, 8 paintings. 8, okay? Pick any 3 you want and bundle them up. My instinct always tells me I'm going to assume the 3 are right here. I still have 8, correct? There's still 8, but these ones have to stay together. So imagine this bundle. I wish I could, I might have to get my iPad tomorrow, but imagine this bundle can be moved over, and then one of these single ones can come over to the left side. And then this bundle can be moved even further, where you've got 2 single ones here, and the 3 is now there. So you can move the 3 around as long as you keep them together. So another thing that's happening is, can you move these 3? Can you shift them around as long as they stay together? Yes. You can make a change in here, and you can make a change of the whole arrangement by just shifting them around. So there's 2 things happening. We're going to say 3 factorial inside this group, because it's 3, 2, 1, 3 times 2 times 1 ways of arranging inside that group. And then you zoom out. You zoom out. This becomes a giant slot. And so let's count how many slots there are to move around if you were to zoom out. 1, 2, 3, 4, 5, 6. It's as if you have 6 now, 6 slots that you can move around, 6 paintings. So let's zoom out like this. And so we'll say 6 factorial when we zoom out. And I will highlight that with the same color that I used for the slots as I zoom out. So the arrangements, right, therefore, the way I would answer a question like this, and maybe let's use this same color here for my grouping, right? So I would say the number of ways I can arrange this is 3 factorial times 6 factorial. Where items stay together, you're always going to have two numbers multiplying for sure. No exceptions, okay? So let's solve this. 3 factorial is 6. You have that on your study sheet. 6 factorial is 720. And so you get 4,320 ways you can now arrange it because you put that extra restriction, that additional restriction on top of it. Okay, that's scenario 1. What if we add another group? The artist looks at her painting again, and she has a group of 3 that she wants to keep together. Let's give that the same color as before. The keyword is staying together. And another one, I'm going to use orange for that. Another group of 4. So she's kind of theming them up. It's like, yeah, I want these 3 always together. I want these 4 always together, okay? How many arrangements are possible now? How many paintings are there still altogether? 8, right? We still have 8. So do that. 1, 2, 3, 4, 5, 6, 7, 8. My instinct just tells me I'm going to bundle up the first 3. And for some reason, I do the other group right beside it. That's how I start off my scenario. So we've got and I think what I'm going to start doing, I change my formula almost every year. I'm going to call this together 1. Like that's the first group that I need to keep together. And I'll call this together 2. So how many ways can I arrange these 3 that are in this group? It's still 3 factorial, okay? And how many ways can I arrange the 4 that need to stay together? 4 factorial, right? That's what you're thinking. So 3 factorial, mix them up as long as they stay together. They're moving around. Now, how many slots are there when you zoom out? This is one big slot that you can move around. This is now a big slot that you can move around. And let's highlight that one painting, poor painting, right? Just loner out there. That, let's go out here. So how many do we have? 1, 2, 3. 3 factorial going out. So what would the answer be in this case? 3 factorial times 4 factorial times 3 factorial. You zoom out. And let's solve this. This would be 3 factorial is just 6, 4 factorial is 24, 3 factorial is 6. That's why I want you to have it on your study sheet, because it saves you a lot of time having to go and get that factorial symbol every time. That's 864 ways. It's a lot less options, right? Because you've got to keep them together, so you can't really, you don't have a whole lot to play with other than, right, staying within their mini groups. Okay. Can I just ask you to color code this if you are color coding? So in my, not everybody does it the same, but that last number is always what I call the zooming out. Okay, that last number corresponds to when you zoom out and you turn that bundle into one slot that you can move around. Right, you count it, 1, 2, 3, 4, 5, 6. That's how I got that. And the numbers that lead are the groups that need to stay together, like the number of items in that group. Same with here, we have the 3, and we created another group where the 4 comes in. Okay. So I'm going to leave it at that for now. I'm going to ask you to try. Now you can try everything up to page 23. So 18 to 23, but knowing that we already have things solved along the way, right? What about this formula, Mr. Erickson? Don't you want to talk about that? I'm actually not going to encourage that formula. I used to do that formula, and a lot of students, they really got confused by it. So I'm just going to say, I will tomorrow give you, at the bottom of this page, I might give you a little bit of a study sheet, like how to do this step by step. But if you can understand the notes, the examples, please practice that. So I'm going to go page 18 for sure. And then page, you already did 20 technically, so 21 to 23 is all mixed up, right? There's some, 21 to 23 has some word problems where you have to be like, oh, these have to be together. What do I do then, right? Before you go, while I have your attention, which one is the universal if I zoom out? Which one is your universal here? No restrictions, right? Let me see if you can do this before you go. If I wanted to know the number of ways where these 3 paintings would not be together, what would I do with the answers that you see up here? I don't want these 3 to be together. Like, how many ways are there that where these are not going to be together? Universal minus them being together. Because you're going to see those questions if you practice, if you do your homework, you're going to be like, finding out how many ways they're not together is way harder than just figuring out how many ways are there where they are staying together. Subtract it from the universal, much easier that way. It's called indirect reasoning. And I want you to get to that place, right? Okay, guys, thank you. Make sure you practice.